Today you're going to learn how the MapRange node works in Blender and how to use it effectively. I will show you different examples to help you to understand it better and how to apply it in your own projects. So let's see. Before we start, you have to understand the main idea of what is MapRange. MapRange is just a converter. The only thing that does is conversions. It takes an input, a value, and it converts it to another value, to an output. And we define the range of values of input and the range of values of output to help the node to make better conversions. So basically, MapRange is just a converter. And now let's see some examples. Okay, to see that MapRange is just a converter, let's go to Geometry Nodes and create a simple example. Let's create a new profile. I'm going to close this. And let's convert, for example, dollars to euros, because this is really easy to understand how we can use MapRange. So let's delete this because I want to work with numbers, and let's bring value. This will be the number of dollars. So let's call this dollars. Let's say that I have $1. Now, before we convert this to euros, I want to see this text here. So let's convert this to a text with value to a string. Remember, a string is a text. And now I cannot connect this here. So what I have to do is to convert this to a curve with a string to curve. Okay, perfect. Now I can connect this here, as you can see. And we have one here. But let's add here fill curve so we can see better this number. Let's select this view and let me hide the background. Okay, so let's enter this and select middle. As you can see, with this value, we can change this number. If you click here, you can add decimals. So now, for example, I can say that I have $5, $10, whatever. Okay, but now what I want is to convert this in euros. So how I can do that without writing here euros? So first of all, I need to know the conversion, the value. And here in Google, we have the information. $1 is this number of euros. Okay. Now, with this information, how I can do this? That always I have in the input dollars, but I want the output euros. So for this, we have MapRange. Let's bring MapRange and add it here. And now, first of all, as you can see, now it doesn't change the value. Why? Because we have this activated. This what means is that the maximum will be 1. That's why after 1, as you can see, we cannot see the real number. However, if you disable this, now it's going to work perfectly. Okay, so we know the clamp is to stop the value with this number. Now, I want to convert this to euros. So we know that $1 is 0.96 euros. So these two values is the range of the input. So in this scenario is dollars, and these two values is the range of the output. So in this scenario, it should be euros. So this is perfect. I mean, $0 is equal to 0 euros, okay? But $1, so this is $1, it's equal to what? Remember, to 0.96. And now, if I press intro, $1 is this amount of euros. Now, thanks to this, I can change the input and it will give me the perfect number of the conversion. So for example, $5 is 4.8 euros. So as you can see, it's just a converter. It's converting with this value to this value based in the input. It's making the calculations to give you the perfect conversion. So for example, if I have $25, it's this number of euros. To see another example, now let's try to convert feet to meters. So let's go here and say feet to meters to know how is 1 feet. So 1 feet is this number of meters. I'm going to copy it. And let's say that we have 1 feet. So let's change this, feet. And we say that 1 feet is equal to this number. But really important, this has to be a point. So 1 feet is this number of meters. If you want to add meters here, By the way, what we can do is to add here join string, and we need to add this here, and here we can add string and select, for example, meters. And if we press space, we have this space. So right now, for example, I'm Spanish, so I don't know how many feet is meters. But now, thanks to this, I can say, okay, I saw that someone is 6.2 feet. How many meters it's? Okay, it's 1 meter, 0.89 meters. Okay, so thanks to MapRange, I'm converting a value, an input, thanks to this range, to another value, an output, thanks to this other range. So with this, we make the conversion. We define the input and the output. So for example, if someone is 5.4 feet, is this number of meters. So, as you can see, it's just a converter. Now that you understand that it's just a simple converter, let's see more examples. Okay, now let's try to convert the unit of time, for example, seconds or frames, to the unit, to the output of meters, for example, with the scale of this cube. So I have this default geometry node set up, and let's try to use transform, because I want to play with the scale. Remember, the scale is based in meters, so now it's 1 meter of a scale, and I can make it smaller or bigger. But I want to play with this with the time. So let's use, for example, a scene time. Remember, this node have the information of the real time in seconds and frame. I'm going to use frame because it's easier to see the value. So now this is 1 of a scale, and if I connect this here in frames, it's going to be the same. Why? Because we are in the frame 1. So this is 1 and this is equal to 1. However, if I change the frame, for example, to the second frame, now the scale is 2 because we are in the frame 2. And if I press play, then the scale increase based in the frame. Okay. Now what we can do is to add in the middle of this process a map range to have more control, to change the range of these values. Now, if I press play, nothing happens. Why? Remember, because this is activated. So that means that the maximum value will be this one. 1. That's why it doesn't change if we press play. However, if we want to not limit this, then we need to disable this. And now, if I press play, it's like before, normal. So usually when you add map range with this, like this, is the same like not using map range. Okay, but now we can change this. So to understand this, remember that now these two values are frames, and these two values is the scale. So the first two values always depend of the type of unit that you have in the input, and the third and fourth values always depend of the type of unit that you have in the output. So for 1 frame equal 1 meter of a scale. That's why if I press play, it's the same, right? But maybe I want to say for 1 frame be 0.1 of a scale. That means that now it's going slower, as you can see. Do you see the conversion? Or for example, we can do the same but different. Look, what I can say is for every 10 frames be 1 value, and it's the same. So do you see that we can play with the values to achieve the same effect? Because now we're saying from 0 to 10, you will be from 0 to 1 of a scale. And then you follow the rule. Or maybe what we can do is, for example, I want that from 0 to 100 frames, so from here to here, you will be 1. Okay, so now it's going really slow. And here will be 1 of a scale. But maybe I want to do this effect in the other direction. So I want the cube to decrease. So the only thing I have to do, I have 2 options. I can invert this and say this is going to be 1 and this 0. That means that at the frame 0, the scale will be 1. And when we reach 100 of frames, the scale will be 0. So if I press play, it's going to decrease. Or what I can do also is to leave this in 0 and this in 1 and invert this. And it's the same, as you can see right now. If it's confusing, then use the one that you prefer. But as you can see, we have a lot of control thanks to a map range. We can define the conversion between the unit we have here. Right now, we are working with frames and with the unit that we have in the output. Right now, we have the scale in meters. Okay, now let's see one of the most common uses of map range, where everyone has to use it, and it's with proximity. When we have an object, and we have another object, and we have a distance, and we want to create an animation where this object or the other change, happen something based in the distance, in the proximity between these two objects. So now I don't want to use time. I'm going to close this and delete this because I want to start again. So we have this cube and I want to play with the scale, as you can see, but based in the proximity, in the distance with another object. So first of all, we need to create another object. I'm going to create a point because it's simple and I want to see this point. So let's add join geometry and let's connect this here to see the point. I'm going to add a dot so it's cleaner, and now we cannot see the point because it's inside. So let's move the position of this point. Okay, now we have two objects. We have this point and this cube with the center, and we have this distance. Now we cannot measure this distance, but we want to get this distance and use it to do something. So let's use the most loved node, geometry proximity, that everyone loves. And now thanks to this, it's calculating the distance between this object and the object that we are going to connect it. So first of all, this is a point. So if I want this to work, I need to select point because this doesn't have faces or edges. Now, as you can see, the distance is a field and the scale is not a field. It's a diamond and this is a cycle, right? So I think they don't like each other. Let's try to see if it's a match or not. It's not a match. They don't like each other. Don't worry. I have been on this, but don't worry, there is solutions. Always you're going to find someone in life that is going to love you. Don't worry. So let's delete this and let's use another node to create a match. So for example, a scale instance. However, as you can see now, we have a scale, but it doesn't work. Why? Because we have a notification. It says, hey, I'm going to work, but with instance. And this is not an instance, okay? So please convert this to an instance. Okay, don't worry. Let's use geometry to instance to convert the geometry to instance. And now it's going to work, as you can see. Okay, so now I think these two people can be a match. So let's see. Yes, perfect. So as you can see, don't worry. Have hope because you can find the love in your life. Okay, now what's happening here? As you can see, we have the point here and something where is happening, right? So if I try to move the position of this point, the scale looks like the same as the distance. Why? Because they share the same value. So basically, the scale, for example, if the distance is 2 between the center and the point, then if this is 2 meters, then the scale is 2. That's why if I try to move the point, this happens. So if we want to control this, what everyone does is to add a map range to have more control, to make a conversion. And now it's the same. However, look, if I try to move this, it's like the same as you can see, but it stops here. Why? Because we have clamp, remember. So clamp is saying, hey, I'm going to limit this conversion to the max value. So if I disable this, now it's like before, okay? It's like not using this. So we want to clamp this because we want to have some control. Okay, so now what is happening is that, remember, the first two values are the input. So right now is distance. And the next values, these two, are the output. So right now, it's the scale. So when the distance is 0, the scale will be 0. That's why if I try to move this point here, the scale decreases until I select 0. And if I try to move it in the other direction, then we invert the scale. And it's getting bigger until the distance is more greater than 1. That's why it stops. Because we have clamp. And we say, hey, stop to 1. It continues, as you can see. So what we can do, for example, is to say, I want this to react until 2 meters. So that means that until 2 meters is going to react, as you can see, or maybe until 3 meters. So until 3 meters is going to react, and when the distance is 3 meters, the scale is 1. But maybe I want to say, look, when the distance is 3, I want the scale to be 0.5. So thanks to MapRange, I'm having a better control. Or maybe I don't want when the distance is 0 to be 0. Maybe I want to be 0.5. And let's change this to not be the same. For example, 1. So when the distance is more than 3, the scale is 1. And between 0 and 3, it will be a scale between this value and this value with the minimum of 0.5. So if I decrease this, you will see that now, if you don't see the point, let me select this view so we can see the point here. When the distance is minimum, we keep a minimum scale, as you can see right now. That's why now the cube don't disappear. So basically what I'm trying to show you is that we have a lot of control to do whatever we want, thanks to MapRange. A lot of people, what does actually is to use this with more objects and instance. For example, really fast, I'm going to add a lot of cubes. Okay, so right now I have a grid of cubes, as you can see. And in the middle we have the point there. And this is not connected. We have a scale. We can control the scale of these cubes. And if I connect this here, now I have this by default. So when the distance between each single instance, because now it's working with each single instance, so when the distance is 0, the scale of the cube is 0. That's why the cube of the middle, so this one, it disappears here, because the distance between the point and this cube is 0. So the scale is 0. However, when the distance increases, then the scale should increase until a maximum of 1. But maybe I want to increase this, so I need to increase the distance of reaction. And that's why now we have this effect. Or maybe what I want when, for example, the distance is 2, so all this out of the range, I want to have a scale of more, for example, this value, or less, maybe 0. And maybe I want to invert this. When the distance is minimum, I want a scale of 1. So now, if I move this point, as you can see, I have this effect. So you get the idea that thanks to this, we can MapRange these two values, distance with a scale. But you can apply this to any project. And now if you ask me, and this, what is this? This is just the interpolation of the conversion. So linear, that means that is like normal. But if we play with these values, we can get different effects. So it's not more linear, normal. Now we have this one, we have smooth. So check the difference between linear and smooth, or this one. So you can play with these values if you want to achieve different effects. If I want to increase the range, increase this. If I want to increase the scale when it's really close, this one. If I want to increase the scale when it's out, this one. I can select this and invert it. So you understand how this works, right? Now I'm going to show you another common use of MapRange in the shade editor. So I'm going to delete this one. And let's disconnect this. So here we have the information of the proximity, but now I don't want to affect to the scale. What I want is to apply colors based in the proximity. So first of all, let's activate the material view. Let's open a new tab to see the shade editor. And first of all, to see this material, we have to go here and add a material. So let's add a material, select the material that we have. And basically what I want is to use this information, this attribute, to send it here. So we need to get this attribute to store it. So we can do, for example, is to use the store name attribute. We add it here and we get the distance and connect it here. And we can call it, for example, distance to make it easy. So now we are storing this information and we can send this information to the shade editor. But to make it work, really important, remember that these are instance. So here we need to select instance because these objects are instance. If not, it's not going to work. So now that we create this attribute, we can send it here with attribute node. And we select distance, and we can connect it directly here. And you will see that nothing happens because, remember, these cubes are instance. So we need to select here instancer. And now, as you can see, it's working. So when an instance is really close to this point, as you can see, it has this color. However, what we can do is to change this color, to map range these colors. So first of all, let's apply a color ramp to have different colors. And now this is reacting to the distance of this point. However, if you want to have more control, what we can do is to apply here a map range. Now it's the same as you can see, but remember, here we have the color. So these two values are the output, that means the color. And these two values are the input, that means that we are working with the distance. So remember, this value is when the distance is 0, and this one, 1. And what is 0 and 1 here? This is 0, as you can see here. This is 0, and this is 1. So from 0 to 1, we are selecting all this range of colors. And we are saying that in the distance of 0 and 1 meter, we want to apply all this range of colors. That's why we have this color reaction from here to here. And everything that is greater than 1, it will be blue. That's why everything else is blue. However, we can play with that. We can say, for example, that we want to expand this if we increase the distance of reaction, as you can see. And now I can say everything that is between 0 and 3 meters from the distance of the point is going to apply all this range of colors from 0 to 1. As you can see, if I move this, it's reacting to the position, to the distance of the point. And also what you can do, if you decrease this, for example, if I select 0.5, what I'm saying is to only use from 0 to 0.5. So this color is not going to appear. That's why we don't see blue, because we are cutting the range of the color. So remember, this is really important. These two numbers is the range of the color. If I decrease this, everything will be yellow. Or if I increase it, we will have more colors, like this one. And if I push it, then it's being smaller. Because we are saying to use this range, but more. So it's like having more blue here. So I hope you understand how this works and how you can use it to apply different colors with any attribute that you are selecting, storing with a store name attribute. To finish, I'm going to show you another project that you can find this tutorial on my channel if you want to learn how to do this technique, where we have two uses of MapRange, here and here. So I'm going to explain you what is going to happen here instead of explain you everything. Basically, it's a simulation. So it's creating this type of cylinders that starts really fast and then slow down, as you can see. So all this is to create this. However, I thought, you know what? I want to change the length of the cylinders based in the velocity. So what I want basically is that when they slow down, the length is shorter. And I could do this. So here we have the scale. As you can see, this one is the scale. And I thought, thanks to MapRange, I can get only the Z. So remember, the Z is this. Let me play again. The Z is this. So if I MapRange the Z as output based in the velocity, okay, all this is getting here. Thanks to this, what I'm saying is when the velocity is 0, the length of this will be 0. And when the velocity is 1, the length will be this number. So after using MapRange, I'm getting this effect. They start really fast and long, but when they slow down, as you can see, they get shorter until disappear, because when the velocity is 0, the length is 0. So that's another use of MapRange, getting one value and converting in another value. And also what I did is to use this information, the length, in the shade editor. So basically what I said is, okay, based in the length, let's apply some colors. So basically, the length here is the velocity. So when the velocity is 0, the color will be 0. So here will be blue. And when the velocity is this one, so almost 1, will be this color, 1, so red. That's why when we start the simulation, they are red, and then at the end, they become blue. Remember, if you want to see how I did this project, you have the tutorial on my channel. And here you can see two uses of MapRange in this project. So as you can see, there is a lot of ways to use MapRange, and now I hope after this long tutorial, you understand better how to use it and how you can apply it in different projects. So if you like this video, please give a like, subscribe, and remember you can donate this project and more than 100 on my Patreon. And see you in the next tutorial.